So the rest of this section talks about arc length and surface area. And arc length is the integration from A to B, don't write this down, of the square root of 1 plus dy over dx squared with respect to x. But when we're in parametrics, they say let x equal f of t and y equal g of t, and t be bounded from alpha to beta. Let's write this in. Let's let x equal f of t and y equals g of t. And then t is between alpha and beta, where f prime and g prime are continuous on the interval from a to b, and c is traversed exactly once as t increases from alpha to beta. Then the length c is the integral from alpha to beta, the square root of dx over dt, quantity squared, plus dy over dt, quantity squared with respect to t. So this is your arc length. The one in red is the one we'll be using. So let's look at a problem using this. The directions say find the exact length of the curve. And it says x equals 1 plus 3t squared and y equals 4 plus 2t to the third. And t is between 0 and 1 inclusive. So we start with dx over dt. So our derivative of x with respect to t is 6t. And then we have dy over dt, which is 6t squared. So our length of our arc, the exact length from 0 to 1, is a big square root, and we have dx over dt, which is 6t, quantity squared, plus 6t squared with respect to t. So we have 0 to 1, so we have 36t squared plus, this makes 36t to the fourth dt. Now you can't just take a square root term by term. You can't break it up. Some people want to tell me this is 6t squared plus 6t plus 6t squared, and that is completely incorrect. But we can factor a 36t squared out of both terms. And we get 1 plus the 36's cancel, and we have t squared dt. So now, because you have two separate terms here being multiplied, you can take the square root of the first term and get 6t. We have the square root of 1 plus t squared dt. You still can't split that and take the square root, so don't try. But we could use u sub. Let's let u equal 1 plus t squared. Then du is 2t dt. So this becomes the integration from 0 to 1. So now we have 6t times the square root of u times 1 over 2t du. Now if these t's right here don't cancel, you messed up. And 2 goes into itself once and into 6 3 times. So this means we have the integration from 0 to 1 of 3u to the 1/2 du. So when we do this, we have 3, and then we have u to the 3/2. So this is a 2/3 here from 0 to 1. So this would give us 3 times 2/3 is just the number 2. And u is 1 plus t squared from up above to the 3/2 power from 0 to 1. Now some of you just always leave the 0 off. You always have to think about it. 1 plus 1 is 2 to the 3/2 power, minus 0 plus 1 is 1 to the 3/2 power. So we could say 2 parentheses 2 to the 3/2 minus 1, and that's a good answer. I would take it. But remember that 2 to the 3/2 means the square root of 2 to the third, which is the square root of 8, which is 2 square root of 2. So we could say 2 times 2 square root of 2 minus 1. So we have 4 square root of 2 minus 2. I'm not sure which one WebAssign wants. This is your prettier answer. Most people understand this bottom answer. I'm okay with either. The surface area formula works very much the same way. It actually is found from rotating your parametric curve around the x-axis. So we say the integration from alpha to beta, 2 pi y, the integral, and then this is the arc length, dx over dt, quantity squared, plus dy over dt, quantity squared, with respect to t, where y is your given parametric equation. So it's not much different from the last one. Let's look at one of these, and it says, so it says let x equal 3t squared, let y equal 2t to the third, and let t be bounded between 0 and 5. Now the directions on this problem say find the surface area when rotated about the y-axis. So here's the difference. This is when we're going around the x-axis for our surface area. So the difference to go around the y-axis for the surface area is S equals the integration from alpha to beta, 2 pi x, square root of dx over dt, quantity squared, plus dy over dt, quantity squared, dt. So whatever letter we're going around, whichever axis we're going around, the other one is the letter here. So the x-axis has the y in the formula, and the y-axis has the x in the formula. We're going around the x-axis here, so we're going to use, we're going around the y-axis here, so we're going to use the bottom formula. So we start off with dx over dt is 6t, and dy over dt. Then dy over dt equals 6t squared. So now let's look at our formula. So go back and look. We're going to be using the bottom formula here because it's the y-axis. So 2 pi x, and then our arc length formula. So s is the integral from 0 to 5. We have 2 pi x, which is 3t squared, times the square root of 6t squared, quantity squared, plus 6t squared, quantity squared, with respect to t. So we have 2 pi, let's simplify that. So we have 6 pi t squared times the square root of 36t squared plus 36t to the fourth. Looks very much like one we did a minute ago, doesn't it? So we have s equals the integration from 0 to 5, 6 pi t squared, square root of 36t squared times 1 plus t squared dt. So we have 0 to 5, 6 pi t squared times, now the square root of 36t squared is 6t. We have the square root of 1 plus t squared dt. So we have the square root, the integral from 0 to 5, 36 pi t to the third times the square root of 1 plus t squared dt. Now the easiest way to do this is u sub. So let's let u equal 1 plus t squared. So du equals 2t dt. Now you see a t to the third right here? That means I have a t squared times a t. So one of those t's is going to be helpful, but let's let this say t squared equals u minus 1. So now we have the integral from 0 to 5, 36 pi t squared times t times the square root of u times 1 over 2t du. So these t's here cancel. And this t squared is going to become parentheses u minus 1. So we got to turn everything to u's before we can continue. So we have 0 to 5. Half of 36 is 18 pi, parentheses u minus 1, u to the 1/2 du. Let's distribute that. So we have 0 to 5, 18 pi. We could put that out front because it's a nice constant. 18 pi. And then we have u to the 3/2 minus u to the 1/2 du. So now we can integrate 18 pi. When we add 1 to 3/2, we get 5/2. And this will be 2/5 minus u to the 3/2. And this will be 2/3 from 0 to 5. Oh, what great numbers. So we have 18 pi, 2/5. Now remember u, let's make this a bracket. Remember that u is 1 plus t squared. So we have 1 plus t squared to the 5/2 minus 2/3 times 1 plus t squared to the 3/2 from 0 to 5. So let's put in 5, and we have 2/5. 5 squared is 25 plus 1 is 26 to the 5/2 minus 2/3. Again, we have 26 to the 3/2 minus 2/5, 1 to the 5/2 plus 2/3, 1 to the 3/2. Remember, we're distributing that negative there. So that's why we have a minus and then a plus there. Now, a decimal would probably be the way most of you go, but I think we usually head with exact answers. So let's factor out of these first two terms, let's factor 2 and 26 to the 3/2. So I'm left with 1/5, and I have 26 minus, when you factor out the 26 to the 3/2 and the 2, this just becomes a 1/3. Minus 2/5 plus 2/3. So now we need to combine these. We're going to say 18 pi, 2. Now 26 to the 3/2. 26 to the 3/2 means the square root of 26 to the 3rd, which is 26 square root of 26. So let's write 26 square root of 26. And here, let's get common denominators of 15. So 3 times 5 makes 15. So 3 times that is 78 minus 5. That should be a minus, not a plus. Minus, multiply by 3 and we get 6. Plus 15 multiplied by 5 and we get a 10. So now we can look at this a little better. We have 18 pi. This makes 52 square root of 26 times 73 over 15 plus 4 over 15 from the two fractions on the end. So we have 18 pi. And then we have, let's make this one long fraction because everything has a denominator of 15. In the first term, we take 73 times 52, and we get 3796 times the square root of 26. And then we have plus 4 all over 15. Now this 18 and 15 cancel a little bit, 6 and 5. And we can factor a 4 out of the fraction on the front. So let's, 4 times 6 would be 24 pi. And let's move the 5 out here. And then when we divide 3796 by 4, we get 949 square root of 26 plus 1. Now that is your most simplified answer. So that's the way that you want to write it. And that gives you surface area. So I think now you really truly have everything to complete the lesson. And thank you.